myself, Dr. Srimantopal. So I'm continuing our class. Last class we stopped here. I hope you have completed writing up to here, right? Up to here you have completed, right? Just put thumbs up. Okay. Aja, in the last class, I got one question. I'm asking you, everyone will answer this. That is very, interesting question. Chalk powder or chalk powder solution. If you mix chalk powder in solution, so what type of mixture you will get? Heterogeneous or homogeneous? Everyone answer this. If you mix chalk powder, acha, video is blurred or clean? Just can you write? So that is our previous class. My question is, chalk powder. So if you dissolve or if you mix chalk powder into water, what type of mixture you will get? Homogeneous or heterogeneous? Actually, last class one student asked this question. Somehow one mistake has been, on that day done. So that's why I am picking that question. Acha. MDP homogeneous. Okay. Andagunda homogeneous, Rishita homogeneous, Vishesh heterogeneous, Ananya homogeneous, Ritika homogeneous, clean. Okay, very good. Video is clean, no problem. Okay, Varun, thank you for your feedback. It is clear, very good. Vihan, okay. See, remember, if we have water and if we mix chalk powder is white, normally white, there might be some different color but normally white. That chalk powder contains calcium carbonate. This calcium carbonate is insoluble in water. Insoluble in water means it will not be completely dissolved like salt and sugar. It will not be dissolved. It is insoluble in water. So that's why you will find some, white colored solution, okay, white colored solution, and compare this solution with milk, like milk and this solution. Milk is heterogeneous and this one also will be heterogeneous. Just everyone write this. Heterogeneous. Okay. Heterogeneous. Everyone just write this. That is heterogeneous. Everyone. So last class, I think this mistake was done. So we are rectifying that. Calcium. Acha, I am explaining again. Chalk powder that contains calcium carbonate. Calcium carbonate is insoluble in water. Calcium carbonate is insoluble in water. If something is not soluble in water, then it will be heterogeneous. Okay, if you mix chalk powder into water, that whole solution becomes white, correct? And it is similar to milk. Consider in that way. Milk is heterogeneous, calcium carbonate solution or chalk powder solution in water, that is also heterogeneous. Acha, Radhik is asking why milk is heterogeneous. So see, I total three examples. Total three examples you have to remember. Do we have okay, here we have space. One is this chalk powder. Everyone just write chalk powder and water. This one. Number two, milk. Number three, blood. These three examples, very important examples. So all these three solutions, not solution, we can say mixture. These are all heterogeneous mixture. The reason is, if you consider blood, in blood, lot of platelets, RBC, okay, white, red blood corpuscle, white blood corpuscle, so many different types of proteins, lot of things are there. So they are not fully dissolved. Similarly, in milk, lot of protein molecules will be there, big molecules. If we see milk, we can say it is homogeneous everywhere. It gives the same taste. But whenever we see through microscope, if you use microscope, you can clearly see this is water, this is protein. Okay, so molecules you can separate. In blood also, if you use microscope, you can easily separate. This is RBC, red blood corpuscle. Okay, this is one particle, that is another particle. You can easily separate. Similarly, chalk powder there. So calcium carbonate, that particle. So from water, you can separate. Point is, you can clearly see using microscope also. Okay. Acha. Mokshit, say whatever we discussed, probably all these videos will be available in YouTube. Okay, you can follow that. So still, if you have any question, you will put in the chat box. I'll explain. Okay. So all these videos, everything will be available in YouTube. Acha. Now Radhika, is it clear why milk is heterogeneous? Milk, blood, and this chalk powder. Same reason. Use microscope. You can clearly see this is particle and others are water. So you can clearly distinguish. Okay. So that channel name, everything will be shared, through WhatsApp. Okay. You will get all those information. Okay. Now let's come to our next topic, sublimation. How many of you know what is sublimation? Can you write in the chat box? What do you mean by sublimation? Have you heard this word? If, be honest, if you didn't hear this one, write no. That's also fine. So I'll explain in detail. Okay, no. Most of you are saying no. Just think. This is very interesting thing. Let's consider we have solid. Okay, this is solid. Now, if we heat this solid, what we will get? We will get liquid. Correct? Next, again, if we heat, then we will get gas. Correct? G. Now, this is two-step process. Solid to liquid, it is called melting, right? It is called melting. Liquid to gas or liquid to vapor. Actually, here gas word is not appropriate. Generally, we use gas, but it is not appropriate. Most accurate word will be vapor, because in case of vapor, other phase, other physical state must be there. If there is other physical state, then instead of gas, we will use vapor. Only gas, if you consider only gas, they do not have other physical state. Okay, like naturally, if you consider nitrogen, oxygen, in nature, liquid nitrogen, liquid oxygen, is it available? No. You can say, sir, we have oxygen gas cylinder, nitrogen gas cylinder. So I have seen liquid form. That is under very high pressure. Nature is not supplying liquid nitrogen or liquid oxygen, right? So if you see what nature is supplying, based on that, we are writing this word. If only one state is present, only one gaseous state is present, means oxygen, nitrogen, carbon dioxide, all of this, so then we will use gas term. If other physical states are present, like water, in case of water gas, that gaseous form, we will not say gas, we will say water vapor, right? We will say water vapor. So another example, because water normally water is available as ice, means solid form, and liquid. That's why that water gas will be called as vapor. Now if you consider iodine, iodine normally is available in solid form. So from iodine, if you get vapor or gas, so we will not say gas, we will call vapor, iodine vapor. Okay, these terminologies are very important when we are using vapor and when we are using gas. So oxygen, it is always gas. Okay, nitrogen, always gas, because in nature, okay, oxygen, nitrogen, they are not available in other state. Only gaseous state is present. That is the extra part. Acha. So solid to liquid, that is melting. Liquid to gas or vapor, so that is boiling, right? That is boiling. Now say the opposite thing. If you consider gas to liquid, it is called condensation. Condensation. Now, if you consider liquid to solid, this is freezing. Okay, it is freezing. So these words you have to know: solid to liquid, liquid to gas, gas to liquid, liquid to solid. Now, sublimation is directly solid to gas. There is no middle state which is liquid. There is no liquid state. Directly solid to gas, if you get, that will be called sublimation. Okay. So solid to vapor form. Whenever we say solid to gas, just now I said whenever we use gas, there should not be other physical state. But now here we are talking about solid to gas, right? Because already solid state is present. Already solid state is present, so we will use vapor. Okay. But in general, if you see normal textbook, most of the textbook, they don't consider all these details. They randomly they use vapor and gas. So don't be confused with that. Vapor will be the most scientific term here, but if you write gas, no problem. Okay. So sublimation is solid to gas. Okay. Is it clear? Sonali, say homogeneous, heterogeneous. A lot of examples we discussed in our class, and I hope you have note that PDF notes. So whatever examples are mentioned, just focus on that. That will be enough. Yes, Radhika, just only solid to gas or vapor form. That's all. Okay, that is called sublimation. Nux, very good, correct answer. Camphor, yes, camphor also correct answer. Camphor always from solid to gaseous or vapor form. It is going right. So that's why that is also sublimation. Yes, if you do opposite, means who is saying Dhanvita. Very good. So your answer is correct. So solid to gas, that is sublimation. If you do opposite, gas or vapor to solid, so that is called deposition. Deposition. Okay. Deposition. Deposition is from vapor or gaseous form on into solid. So again, I'm saying don't be confused with gas or vapor. If someone is asking, define this. Vapor will be used if other physical states also present, and gas will be used when there is no other physical state. Just write down this one. But normally, gas or vapor, whatever we say, we mean the same thing. Other than solid liquid, that is the third phase, third physical state. Correct? Achha, now Acha, now boiling as Vishesh is asking, can we call boiling as evaporation? So there is one thing. This boiling requires a specific temperature. For water, it is 100 degrees centigrade, correct? But if you consider evaporation, there is no such temperature requirement. Evaporation can happen before boiling point. Example, if you put some water on the floor, now the temperature in this floor or in this room, it is 20, 25 or 30 degree maximum, right? It is not 100. It is only 25 to 30 degree. Still, after some time, maybe half an hour or 1 hour, that water will be evaporated. So that evaporation word will be used when temperature is below 100 degrees centigrade for water, means below boiling point. Okay. Yes, naphthalene balls. That is also correct, Dhanvita. Gas to solid deposition. Radhika, correct. Okay. So clear now? Till now, all these definitions. Bhavagna, the process in solid changed into a gas without turning. Yes, Bhavagna, you are correct. Yes, just write down, because if you write somewhere, on your classwork, it will be easy to recall. Just you will revise one time. In future, you need these words. Lot of, especially in physical chemistry. Chemistry, we have three, subfield, we can say: physical chemistry, organic, and inorganic. Mostly these three. Others also there, like analytical chemistry, so nuclear chemistry, that is different. Normally, physical chemistry, physical, organic, inorganic. So in physical chemistry, we need all of these. Lot of numerical questions will be there, and there you will see lot of words like this: freezing, melting, condensation, boiling, deposition, sublimation, all of this. So that's why these things should be clear to you. Okay. uh, Bhavita, what you are not understanding, please write that question, which part, which one. Otherwise, so many things I'm saying now, how I'll understand which one you are not understanding. Priti, what you asked? See, Vidarya, you are saying liquid oxygen to oxygen. Nature is supplying liquid oxygen? No, right? In nature, in our environment, always oxygen is available in gaseous form. How we are getting liquid oxygen? Because scientifically, we are compressing that liquid, we are compressing that vapor. Oxygen, are I am doing mistake. We are compressing oxygen gas into liquid under high pressure and low temperature. We are converting oxygen gas into liquid under very high pressure and low temperature. So that's why we are converting oxygen gas into liquid. Nature is not giving. Here what I said, what nature is supplying, stable form, right? So that thing you have to consider. Acha. Now here we have a definition. I hope this part you have written, right? Just put thumbs up. Then I'll erase this part, because under sublimation, lot of things you have to write. This part is you have written, correct? Very good, very good. Okay. Let me erase this part. Okay. Now just write. These are the text. This technique of separation of a mixture of solids can be used if one of the constituents of the mixture sublimes. So imagine if we have a solid mixture, and there let's consider naphthalene or camphor or iodine present, okay, and other like sand also present. So naphthalene balls and sands, these two are solid substance, so they are mixed. Now how we can separate these two things? Easy things, just heat for some time. So this naphthalene will be converted to gas, right? And sand will be remaining in the container. So naphthalene and sand you can easily separate using sublimation. So why it is sublimation? Because you are getting solid to vapor or solid to gas. Clear? So that's the thing. So heat, you have to do heating, changes directly into gaseous state without passing through the liquid state. Substance that sublimes are, see here examples are there: iodine, camphor, naphthalene, ammonium chloride, and dry ice. A mixture of ammonium chloride and sodium chloride can be separated by sublimation. Acha, now here dry ice. What is dry ice? Do you know? See, naphthalene balls is available now. If you go to the market, that small white, mostly white color, small balls are available. They are selling, and where we put that in clothes, so that there should not be any other insects or something, right? So in that naphthalene balls you have seen. Solid form, yes. What is dry ice? Varun is saying solid form of CO2. Very good. So just now I said liquid. See, liquid oxygen to gaseous, liquid to gas, that is not sublimation. Sometimes before someone asked that liquid oxygen to gaseous form, always remember liquid oxygen that is not available or that is not stable in atmosphere. Okay, if you just open that box, immediately it will evaporate it, or immediately it will become gas. But if you consider dry ice, if you have dry ice, solid form of CO2, it will be stable under atmosphere, and slowly that solid to gaseous form you will get, right? So in this case it will be called sublimation. So sublimation is, always remember, solid and gas. These two things you have to remember. Liquid to gas we cannot say. Solid to gas you have to consider. Okay. Achha, ammonium chloride. See, just like naphthalene, camphor is another type of compound. Iodine, I2, and here see structures will be very big. These two are organic molecule, so big molecular structures, big structures will be there. Ammonium chloride, that is short form, you can write NH4Cl. NH4Cl, ammonium chloride. So if you heat, so that will be converted, that will generate gaseous substance. Only this much we have. Just write and put thumbs up if you're done. Shubhas, yes, I can see your chat, but just write what is your question. stay relevant to this topic, because in chemistry thousand and thousand questions we have. Okay, so be relevant to the topics. Regarding this, whatever you have, just you can write in the chat box. Yes, I can see you. See those who are writing, I can see all of your chat. Okay, just write your question. Vavagna, then Andagunda. Yeah, I'm not sure this is your name. This might be your initial name. See, example, Shohil is asking example of deposition. See, normally we don't use in our regular life, but whenever you visit any lab, in lab, big machines we have, and there, for example, you have one iron, okay, iron substance. Now you want to deposit gold on this iron. There are two methods. One is electrolysis. Just you can write this thing, electrolysis. Electrolysis. And second one, deposition. So in electrolysis, that is different thing, but deposition you can easily understand. So here we have iron rod and we are converting gold into its vapor form by heating, by supplying enormous amount of heat. So now this gold is in vapor form, and now slowly this gold will be deposited on this iron. Okay, uniform deposition you will get. So this technique is very much useful in, especially in engineering chemistry. Okay, to coat something, for example, you have one substance, you want to coat that substance with other element, so there deposition is useful. Achha, just one. Okay, just rewrite your name, because here you know what I can say, that one I'm that name I'm taking, just rewrite your name in the account section. Okay, just Srikar, yes, I can see your chat. Nived, correct? This part is done or not? Just write in the chat box if it writing part is done. Okay. Next part. Achha, now questions. We have so many questions. Let's see. First question. Everyone try to answer this. Components of a mixture separated by sieving done based on. So this sieving method, in which case we used? What will be the answer? Whether yeah, just write one time. Otherwise, why you are writing so many times? Yes, you are correct. Nags also correct. Shivara, Naga Shivara, correct. And I can't. Space is there. There is no name. Manivit, correct. SCH, who is this? Just rewrite your name. Otherwise, how can I take your name? Your answer is wrong. Check again. Nived. Remember, just see that writing. You wrote one paragraph based on this, right? Saving. Most of you are writing correct answer. Are saving means, let's consider this one. Okay, so many, these are there, so we can consider these are like pores, correct? Now if we put some big stone here, if we put some big stone, it will not go through this net, right? Or sieve, we can say it will not go through this sieve. But if we put some powder form, it can easily go. So that's why you can see big size and small size. Big size particles, they cannot go through this, but small size particles, it can easily go through this. Okay, so answer should be D. Let's say answer is D. Okay. Our channel name, everything will be shared in the WhatsApp group. Don't think that we are uploading and you are not having this information. Don't think in that way. If everything is uploaded, then automatically you will get information. Okay. Okay. Chalo, next question. This one. Everyone try to answer. Everyone try to answer. Sanvika, very good. Aradhya, correct. Varun, correct. Darshini, correct. Vidarya, correct. Naks, correct. Mushani, correct. Vidarya already. MDG, correct. Vidarya, how many times you are writing? Manvit, correct. Manivit. Bhavita, Are, your answer is wrong. Bhavita, I'll explain all of this, okay? Don't worry, I'll explain all of this in detail. Prathamesh correct, SH correct, Somepalli correct, Nived, think again. Nagasivara correct, MDP, yes correct. Nived, think again. Ananya correct, Srikhar. Yes, so many students are writing. Most of you, 95% students are writing correct answer. Acha. Now just say camphor and sand. If we heat camphor from solid, it will become vapor form or gaseous form. Sand will be remaining, right? So solid to vapor, what it is called sublimation, right? Solid to vapor or solid to gas. Crystallization. What is crystallization? Let's consider here we have water of, we are adding, let's consider NaCl, not NaCl, copper sulfate. Let's say copper sulfate. So we have water, we are adding copper sulfate, and then we are heating. So all copper sulfate molecules, they will be dissolved, correct? Now what we are doing, slowly we are doing cooling. Okay, cooling. So now, and we are putting one rope into this solution. And what we will observe, that with time, on this rope or following this rope, so many big deposition is happening. Deposition means we can consider, this is not actually deposition, we will consider crystallization. We will get a lot of crystals. These are actually crystallization. So in case of crystallization, first we have to heat that sample, then slowly we have to cool, then we will get proper crystal substance. Okay, so getting crystal substance from amorphous, left side it was amorphous solution, left side we had amorphous, from that we are getting crystal following this heating and cooling process. So that is crystallization. Okay, that is crystallization. And now what do you mean by crystal? See, whenever we say amorphous, okay, like this, and Now, if I ask you, is there any similarities between left and right picture? What you will say? Left side picture, there is no similarities. All are in random. All particles they are positioned in random way. But right picture, you see, proper geometry is there. All particles they are present in a proper format. Means this is ordered structure, and this is disordered or random. Disordered or random structure. So this left side structure we will call amorphous, and right side we will call crystal. So any crystal structure means all particles they are in ordered way. Okay, ordered structures are present. That is crystal. Okay. See, you are saying left side is gas, but you just think if you do in this way, fill all of these. Now you can't say this is gas, right? Now you can't say this is gas. Do you have any similarities? No. It is a random, structure or disordered structure. Correct? So crystallization or crystal means always remember ordered structure. Acha. So crystallization will not be the answer here. Evaporation. Now evaporation means liquid to gas or vapor form. Liquid to vapor form. Okay, so here both are solid. Camphor and sand both are solid, so this will not be applicable. Now distillation. So distillation means under distillation we have several methods. Fractional distillation. Okay, that is another one. So distillation means both should be liquid. Normally, in normal case, both should be liquid, but here both are solid. So here also not applicable. Okay. So now, see, distillation normally liquid, that is actual fractional distillation. Whenever we have distillation, for example, liquid and solid, if we evaporate, if we give heat, all liquid will be converted to vapor and solids will be remaining, right? That is also called distillation, but this is a big topic. Under this, lot of subtopics we have. So in detail, in future, we will study. Okay, but normally, in normal context, we can say that distillation means liquid must be there, but here both are solid. So that's why distillation will not be the correct option here. Clear up to here? Yes, you can drink water. Up to here, is it clear? So here answer, let's see the answer. Answer is A. Vokia, what is your, if you have any question, just write down the question. Okay. Otherwise, how can I, identify your problem if you have any doubt? Always directly write your doubt. Okay. Clear. Okay, chalo, next question. This one. Everyone. Book here, sublimation means solid to vapor form. That's all. This process is called sublimation. If you have naphthalene balls, that is solid, right? From that, you will get vapor sublimation. Correct? So camphor, that is also solid. At room temperature also, slowly it will become vapor form. Vapor. So that is also sublimation. Dry ice, which is solid form. From that we will get directly carbon dioxide gas. So that is also sublimation. So anything from solid to directly gas, this process is called sublimation. Is it clear? Vukia, that part is clear? Achha, here most of you are answering D. Few members, they are saying C. Let's see. The process in which a mixture of heavier particles and lighter particles are separated by the wind. See, already this what is mentioned during class also I said, if wind, this what is mentioned by default, answer should be winnowing, right? Let's see the answer. So D. Clear now? Those who are answering wrong, only few students they are answering wrong. I think they are not, they didn't revise that classwork, class note they didn't revise. That's why they are doing mistake. Okay, crystallization, just few minutes ago I said crystallization means this is the process of getting crystal. Crystallization is the process name. Okay, first you have to heat, then you have to cool. From disordered structure you are getting ordered structure. Ordered structure means crystal. So getting a crystal, how you will get a crystal? So that you must follow some process, right? That process is called crystallization. And deposition means opposite of sublimation. From gaseous or vapor form, if you convert that into solid, deposition. Okay, correct? Acha, thrashing. So here thrashing. So you have to apply force, right? You have to apply force. Then only remember that grains, paddy grains. So there, if you put some force and beat that, then only all those grains particles will be separated, right? Thrashing. Then reaping, harvesting, winnowing. So these all terms, these three terms are connected to farming. And winnowing, this is in general, in regular life we use this. Okay. So next question. This one. Everyone try to answer. Gayatri, within 3 seconds you are answering. Very good. But let's see whether your answer is correct or wrong. Naphthalene balls reduce in size due to. Gayatri, your answer is wrong. Aradhya, very good. Your answer is correct. Darshini, correct. Prathamesh, correct. Chinmay, correct. Bhavita, think again. Just now I said. Srivastava, correct. Radhika, correct. Surya, correct. All correct. Who did? Amruta, think again. Nived, none of this. Think again. So most of you are answering correct. No, very good. So let's see. Filtration. Achha, first read this question. Naphthalene balls. So this is our naphthalene balls. Slowly, with time, its size is becoming smaller and smaller. What is the reason? So filtration. What do you mean by filtration? Let's consider we have one, mixture. Water is there, and lot of particles are present. So we will use filtration means one filter paper will be there, one funnel will be there, and filter paper, you have to put filter paper here. Okay, you have to put your filter paper here, and filter paper is having lot of pores. So now if you put this solution into this funnel, then all those particles will be remaining on this filter paper, and water will be below this. So filtration, there are two terms. One is filtrate, okay, and another one is residue. Residue is this. Means here I said na, water and some particles are present. All those particles will be collected here. That is called residue. And water will will be going through this filter paper, and slowly drop by drop it will fall and we will collect. This is called filtrate. Okay, so this is called filtration technique. Now sublimation means solid to vapor form. Now check here, this naphthalene ball, we know at room temperature also this solid will be converted to vapor. So now see, initially this was the size, so now this much size already converted to vapor. Now again from surface it is converting to vapor. So sublimation is the method by which these naphthalene balls are reducing its size. Okay, so answer should be sublimation. Now evaporation is what does it mean? Liquid to vapor. Naphthalene is solid, right? Naphthalene is solid, so here we can't take this option. None of this by default is wrong. So answer is B. Clear up to here? Any doubt? Ananya, how your answer is? Evaporation is one must be liquid, right? Liquid to vapor, right? But here naphthalene balls, it is solid. So how it can be evaporation? Meghna, yes, I can see. So filtration, so this is called residue. And DUE, and this is called filtrate. Okay, residue, filtrate, that whole process is called filtration. Vedasri, the process of Vedasri is saying the process of removing insoluble impurities using a filter paper is called filtration. Very good, perfect answer. Our break is 9:20 now. 1 minute. Acha, up to here is it clear? Up to fourth question we have discussed. So tomorrow we will continue up after this. Till now, whatever I discussed, is it clear to you? Put thumbs up or write in the chat box. Is it clear? Bhavita is writing, yes, I'm so happy that you had so many questions. So that is already resolved. Very good. Up to here all are done, right? All clear? Yes, yes, yes. Okay, clear. Thumbs up. Very good. So tomorrow, since we have more few questions, 6 questions we had, revise. Okay, whatever separation techniques we have already we studied, just read one time. Okay, very good. Chalo, we will meet in the next class.
Okay, most of you know me, for who have recently joined. Okay, myself Vivek Roy Chaudhary. This is the mathematics sessions. We're going to start now. Okay, fine. Sure. Yes. Good morning. Good morning, all. Good morning. Good morning, everyone. Okay. Done. Okay. So let us start without any further delay. Okay. Ready? Okay. So last class we have discussed this, correct? So that is different way of representation. That is different way of representation. What is this kind of representation? This is what representation? Two way of reading our particular decimal. Okay. So first way, let us suppose 103.919 is there. Okay. So 103 and 1900. So here we don't say as a point. Okay. So point we don't say. Instead of this, we say it as, okay, we put a word and in between. Okay. So here because only 0 is there, so 13,000 here and because here nothing is there, so that's the reason there is no and. Or else we will add a and in between them. We will add a add in between them. Clear? Is it clear to everyone? Clear to everyone? Done? Yes. Any doubts here? Yes, that is the repeated part is this is the and part. Okay, the two-way of reading a given decimal point, two-way of reading the two given decimal point. Okay, one is there is a and in between them, and one is the point in between them. Okay, clear to everyone? Yes, absolutely clear. These 2 points. Okay. So why will we not say point? There are two way of representation, Baba. These are the two way of representation. Okay. Yes, I can see everyone chat. You don't have to worry about that. I can see everyone chat. It is right here. I can see everyone's chat. Okay. You don't have to worry at all. Okay. Fine. Yes. Good morning. Good morning. Good morning, everyone. Okay. Still good morning, then late to the class. That should not be done. Okay. Be on time, leave on time. As simple as that. Okay. Yes. Fine. Any more doubts? Any more doubts from the previous class? I just want to take up few doubts before I dig into the chapter. Any more doubts in decimal? We have not started much, just the rim part of it. Okay. Any doubts? Please let me know. All good, all good. Thanks for asking, Vihan. All good. Anyone? Can you see my chat? I can see all the chat. You can see right over here. I can see all the chats, guys. You don't have to worry at all. Okay. This you have already copied, Baba. This was the last class. This is nothing new I am teaching currently. This was there in the last class. Okay. Anything else? Anything else? Please let me know. Everyone's chat I can see. Good morning. Good morning. Hello. Okay. Sir, I didn't attend the last class. Even online class you are missing. That should not be done. I have a doubt. Please ask me quickly before we dig into the chapter. Okay. Today's topic, it would be both the periods are maths. The second period that is currently and the third period. Okay. Chalo. Fine. Let us start. Okay. Yes. So write the place value of each digits. Okay. Place value of each of the following digits. Okay. So before I want to write down the answer, I want every one of you to write it down. Okay. I want everyone to write it down. Try for it, everyone. Everyone, please try for it before I write down the answer. Okay. Everyone, try it up. Let me know the answers. Let me know the answers. Make it quick. I hope I am clearly audible. Screen is blurry. No. Because I have joined from my device also, I can see it pretty much clearly. Okay. Good morning, everyone. All good, Baba. All good. Thank you for asking. Okay, correct. Okay, so let us write each and every value of it. Okay, so 148.154. Okay, so this one. Okay, so the first one. Okay, this is in hundreds place. Okay, this one is tens place. This one would be in ones place. This one will be in tenth place. Okay, th. This will be on hundredth place. Last, thousand place. Okay, and obviously the center one is the point. Okay, any doubt here, please let me know. Any doubt here, please let me know. Anyone having any sort of doubt here, please let me know. Very simple question. Where is the point, sir? The point is there. I think so. Now you can see the point. Very good, good. Printed copy is fine. Okay, absolutely there is no issue with the printed copy, but that doesn't mean you will not write. Okay, absolutely not done. Okay. Can we write in expanded form? This is the expanded form. That is 1 hundredths, 4 tenths, 8 ones, 1 tenth, 5 and 500th, 4,000th th. Sir, I think 1 after the decimal is in hundredth. 1, no, that would be tenth, then hundredth, then thousand. Can I drink water? Yes, please, Baba. You don't have to ask for water. Okay. So, do you know one member in the class? He is my old school friend. Okay, very nice. Good. It's good to get old friends back. Okay. Done. So, after point, we should say individual numbers. Yes, exactly. So, that is 148.154. Perfect answer. Very good. Okay. It's good to come get back your old friends. Very nice. Good to hear. Okay. Good. Chalo. Can you move on? Is it okay? I hope there is no doubt here. Okay, let's move to the next one. Okay. Next. So a decimal, okay, a decimal fraction, okay, a decimal I want to convert, okay, I want to convert it into a decimal format. How? Okay, how should I convert it? Okay, decimal fraction into a decimal. Okay, please follow the steps. First, write the numerator in the decimal format. Okay, decimal form. Okay, move the decimal point to the left as many decimals as there are zeros in the denominator. If there are not enough digits in the numerator, then add zeros to the left of the number. Okay. Now let us see a beautiful example which is already there on the board. Okay. What is there on the board? Please look into it. Okay. See. This is 6 by 10. So what they have said? Decimal points moves towards the left of the place. Okay. Left of the place. Okay. left of it. So you can see the decimal goes towards this side. Okay, this is my left side, this is my right side, correct? So decimal 6 is 6 point is there, 6.0. 6 and 6.0, there is no difference. So point is moving towards the left side. So it is becoming 0.6. Okay, it is becoming 0.6. Okay, move to the left side. Now, 8 by 100. Okay, 8 by 100. Now see, how many digits it has to go? How many digits it has to go? 2 digits. Because how many zeros are there? 2 zeros. Okay, how many digits are there? 2 zeros are there. It has to move 2 digits. But there are no 2 digits with 8. What he will do? Simply add a, okay, that is add zeros to the left. That is, okay, there is no difference between 8 and 08 or 008. You can add as many zeros as you want here. This side, yes or no? Yes or no, guys? Correct? Yes, we can keep on adding towards the left side. Correct? Yes or no? So, similarly, okay. So, as I am need of 2 digits, why I am need of 2 digits, Baba? Because I have 2 zeros. Because I have 2 zeros. Okay. That 2 zeros, okay, that 2 zeros which are there, these 2 zeros, okay, these 2 which are the zeros, okay, clear to everyone? Yes? Clear? Okay. So, I have to move 2 digits. As there is only 8 one digit, I have add one more 0 towards the left. One more 0 towards the left. Now see here, 15 by 1000. 15 by 1000 is there. 15 by 1000, how many zeros total? 3 zeros. But there are only 2 digits. So what I will do? I will put a 0. Now there are 3 digits. Now put a decimal point. That's your answer. Check it. 0.015. Understood here? Okay, sir, didn't understood. Okay, one more time. Then one more time. Okay. Please listen to it. Stop writing, everyone. Okay. Stop writing. Writing and listening won't be happening in parallel. Okay. First, stop writing. Look at the board. Okay. See here. First, left as many zeros as it is there in the denominator. See. Please look into it very carefully. There is 6, one digit, and there is 0. There is no issue. It became 0.6. Okay. 0.6. Now in the second case, it is 8 by 100. 100 means how many zeros? 2 zeros. 100 means how many zeros? 2 zeros. Now, but 8 is a single digit number. So instead of writing 8, I am writing as 08. Can I write like that? Yes, I can write like that. So it will become now 0.08. It will become now 0.08. Same goes with 15 by 1000. How many zeros? 1, 2, 3. How many zeros? 1, 2, 3. Now, there are only 2 digits. How can I make it a 3-digit number? By adding a 0 at the front. By adding a 0 at the front. That's it. Now the decimal point will be here. Same. 0.015. 0.015. Is it clear now? Any doubt here? Please let me know. People who had doubts, still there is a doubt, please let me know. People who had doubt, please let me know. Can you explain the last one? Okay. See, I am repeating again the last one. Okay, that is 15 by 1000 is there. 15 by 1000 is there. 15 is a 2-digit number, but how many zeros are there? 3. 1, 2, 3. So I have to make this 15 a 3-digit number without changing the number. How can I make it? By adding a 0. By adding a 0. Okay, clear? So now I will place the point before this 0. So it became 0.015. 0.015. How to read this? 27.186. Yes, you have to copy this. Okay, you have to copy this. Everyone, once understood, please note it down. I am waiting for 1 minute. Okay, I will wait for 2 minutes. Okay, write along with the example. Okay, along with the example, it is important. Sorry, yes, go for it. Please start writing. Very, very important. Okay, once done, let me know. Yes, you have to write it out even if you have taken the printout. Please have it. Please have some water, no issues. Please hydrate yourself. Ready, everyone? Done? Done. No, sir. Okay. Make it quick. You will get your summer breaks. Don't worry. Quick, guys. Energy. Quick. Once done, please let me please update in the chat box. Speed up. I have to go bit slow because few of them have just joined. Okay, so that is the reason I'm going bit slow. Don't worry, we will speed up in the question part whenever it is needed. Okay. Done? Okay. I hope it is done now. Yes? Oh. Chalo. Let's move to the next. Okay. Normal fractions into decimal. Although many of you have asked this. Okay. Many of you have asked this. That is, normally, how should I convert? Okay. Should I convert? So to convert a fraction into decimal, okay, convert into its equivalent fraction with denominator as 10 or a multiple of 10. Okay. I know in all the cases it is not possible. In few of the cases they are possible for them. Okay. That's why a normal fraction they are talking about. Okay. So as 5 is there, you can group 5 with 2 and make the denominator 10. Okay. So that is 4 by 5 is there. Multiply numerator and denominator with 2. So you will get 8 by 10. 8 by 10 again 0.8. 8 by 10 is again 0.8. Okay. Clear? Yes. Next. 3 by 4 can be made into 100. How? Multiplying 25 and 25 both numerator and denominator. Okay. 25 both in numerator and denominator. Okay, so 25 into 3, 75, 25 into 4, 100. So 75 by 100, 0.75, 0.75. Clear? Yes? Done? Next. 5 by 8, 5 by 8 is there, 5 by 8 is there. So now I am multiplying with 125, I am multiplying with 125 to make it 1000, both in numerator and denominator. Okay, if we are multiplying any given number to numerator, the same number I have to multiply to denominator. Okay, I hope it is pretty clear in this point. Okay, or else it will change the fraction completely. Okay, I hope this point is very, very clear. Okay, good. Please ask me the doubt. Okay, so 8 into 125 and 5 into 125. 125 into 5, please do it. You will get 625. 625 by 1000. Okay, clear? Done. Now decimal to fraction. First take this as a note. Then we'll move from decimal to fractions. Make it quick. Can you explain first one? See, I am trying to make the denominator into 10. So how can I make 5 in the form of 10? By multiplying with 2. So I am multiplying both 2 in numerator and denominator. Same goes with the second one. 4, how can I make it into 10? I can't make it into 10. So I am making into hundreds. So 4 into 25. Both 25 multiplying in numerator and denominator. Same goes with 8. I cannot make it into 10. I cannot make it into 100. But I can make it into 1000. Okay. So 8 into 125 and 125 both in numerator and denominator. Okay. Clear? Baba. 125 both in numerator and denominator, so that 8 is converted into 1000. Clear to everyone? Pranav, is it clear? Done, sir. Done. Okay. Once can you what, Kriti? Once what you want? So why should we multiply with 25 and 125? The reason to convert the denominator into tens, hundreds and thousand. 99 by 100 would be 0.99, not 0.099. Convert your denominator in the form of tens, hundreds and thousand. Okay. To convert 4 in the form of tens, I multiplied with 2. To convert 4 in terms of 100, I multiplied 4 with 25. And to convert 8 in the form of 1000, I multiplied 8 with 125. 8 with 125. Okay, I hope it is clear. Okay, done. Clear? Okay, let's move to the next part. Okay, so while converting, that is the next topic is converting your decimal point to decimal fraction. Okay, fine, decimal fraction. So that is in short converting into fraction. Okay, So while converting a decimal, that is converting a decimal into a decimal fraction, write down the decimal part as numerator, okay, and the denominator becomes a multiple of 10 with the number of zeros same as number of decimal places, Now look, see now, first 1.12 is there. So I simply wrote what? 112 divided by, why divided by 100? Why not with 10 or 1000? Reason being there are two digits here. So divide by 100. There is only one digit after the decimal point. So 10. There are three digits after the decimal point. So divide by 1000. Very, very simple. Okay, please look into it. Okay, these decimal point entire short definitions. Okay, I am waiting for you to write the entire definition. If I am waiting means you have to write that particular definition and example. No, Baba, you have one more class after this. Chitra, there are, look into the example. There are two decimal digits, okay, in the first one. What are those? 1 and 2. So divide by 100. In 15.4, there is one digit after the decimal point. So divide by 10. In the next one, there are three digits after the decimal point. Okay, so divide by 1000. Break at 10:20, Baba. Next class is also maths. I hope any doubts, please let me know. And I would request, instead of just saying sir doubt, explain your doubt. Okay, that would save your time and my time also. Okay, with the doubt, ask the question itself. Okay, please have some water, Baba. Please hydrate yourself. Okay, 3 long 50 minutes classes. Please hydrate yourself. Homework is, we are discussing few of the question in the worksheets. The rest of the questions which are there in the worksheet are itself the homework. I hope everyone understood that we are doing only few selected questions from the worksheet. Any doubt, please let me know. Oh, sir, I don't understand the example. First of all, your name is not visible properly. Okay. Can you rename yourself so that I can address you? Sir, after the online class will end, sir. Okay. What are the questions from the worksheets? You will look into it. Mokshit, yes. Normal, can you explain again normal fractions into decimal? That is converting your denominator part into tens and hundreds. That is, let us suppose 5 is there. So 5 you need to multiply with 2 to get 10. So multiply both the numbers, that is your numerator and denominator, with 2. Okay, fine. Let's move to the next part. Decimal into normal fractions. Okay, decimal into normal fractions. Okay, so once we convert, convert the same process. Okay, same process, one step extra. What is the one step extra? One step extra is simplify the fraction. Okay, so the same example we can take 1.12. It is 112 divided by 100. But upon simplification, we can write it up upon what? Okay, upon simplification. I hope everyone knows how to simplify this. 112 divided by 4 would be 28, and 100 divided by 4 would be 25. So, which will give 28 by 25. Same here. Okay, 154 by 10. So I am dividing with 2. Okay, why only with 2, sir? Because that's the HCF, sir. That is the HCF of 154 and 10. Okay, HCF means highest common factor. Now 175 divided by 1000. Okay. So in short, you have to keep on dividing until and unless there is no common factor between numerator and denominator. That's the meaning of it. Okay, that's the meaning of it. Now here I am dividing with 25. Why I am directly getting? Because I know the table of 25. Okay, 25 7 is 175 and 25 4 is 100. So I multiplied with 40. So 25 into 40 would be 1000. I hope it is clear. Okay, means we need to find the HCF also. If yes, there is a lot of work. No, you don't need to find HCF all the time. Okay, for example, let me tell you, 112 by 100. Okay, divide with its common factor. With HCF it will be quick. Okay, with HCF it will be quick. Can you divide? Can you see it is divisible by 2? Yes, it is divisible by 2. So what is this? This will become 56 by 50. Again you have to divide with 2. If you are not dividing with HCF, you will get 2 extra steps, 2 or 3 extra steps. But your final result will not change. See, what I have done here, I have divided with 2, I got 56 by 50. Again divided by 2, I got 28 by 25. Okay, 28 by 25. Okay. Okay, clear? Any other doubt? Let me know. Oh. Clear. Done. Break, you will get in another 10 minutes, Baba. Yes, you have to write them up. I am waiting for that only, or else I could have moved to the next slide, right? I am waiting for you guys to write it down. Okay? Once done, let me know. Any doubts, guys? Please let me know. I can see all the chats. See guys, let me tell you, I can see all the chats, that's for sure, but there are thousands of messages coming at the same time. Okay, I am just answering to those questions, okay, which I can see on that particular spot time. Okay, fine. I'm trying to answer everyone. If anyone is getting missed, okay, don't worry about it. Important question will be taken up in the Saturday's class. Okay, you don't have to worry at all. Okay, 90% I am making it sure that I don't miss any of the questions. Still, if there are any doubts, okay, please note it down. Okay, that we will take it up on the Saturday's class. Okay, fine. Sir, is 40 a multiple of 10? Yes. Yes, 10 into 4. 10 into 4. Okay. Done, everyone? Done? Okay. Sir, can you speak in Telugu? Yes, I can. Okay, but I am trying to avoid it. Okay, because there are multilinguistic people joining the class. Okay, fine. I hope it is, sir. Can you move? Okay, okay. So English, I feel it is better from both the end. Okay, done. Which there is nothing, no need to write. There is only one statement. There is nothing to underline here. Okay, it is one given statement. You have to write down the complete statement. Okay. Sir, I am blurry. I am blurry. I am also not clear. I can see myself pretty much clear in the my device. Okay. Done? None. Yes, I am born in 2000. Okay. Done. Done. Chalo. Let us start. Okay. So one more method. Okay. So that is dividing. Dividing, that is writing in the form of this, that is writing in the form of mixed fraction. Okay. Writing in the form of mixed fraction. That is very simple, pretty simple. Okay. Look into it. This 1 point is there. So 1 is what? A whole number. 1 is what? A whole number. Same here, 15. 15 is what? A whole number. Which is the fraction part? That 0.12. So 0.12 I have written as 12 by 100. That's it. Here, what is the fraction part? 0.4. So that I have written by 4 by 10. Let me repeat again. Okay. First, before, that is the left hand side of the decimal point, are nothing but what? Whole numbers. So 1. 15, 15. Okay. Now, which is the decimal part? Which is the decimal part? Point. Okay. So this, in short, look, this I can write 1 plus 0.12, and similarly here I can write 15 plus 0.4. So this 1.012 can be written as 1 this, and 12 by 100 as 12 by 100. Why? Because of 0.12. 2 digits after the decimal point, so divide by 100. Same here, 15 as it is. Okay, and this 4 by 10 is because of 0.4. I hope it is clear to everyone. Clear? Clear to everyone? You should move. Okay. Done? So break it as 1020. Yes, Papa. Break it as 1020. As I said, 2000. Please speak in Telugu, that we will see in the offline classes if it is possible. Okay. Done, 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 done. Sir, I didn't understand the alternate method. See, 1.12. I wrote it as 1 plus 0.12. Okay. 1 you write it as it is. Okay. And 12 by 100, 12 by 100. Why 12 by 100? Because of 0.12. Okay. 0.12, how will you write in fractions? 12 by 100. Okay. Can you speak in Hindi? Yes, I can. Okay. That's the reason I'm sticking to English. Okay. Where do I live? I live near ECL. So can you move? Okay, okay, okay. Sorry. I hope it is visible. Is it done? That's it. That's it. Good, Rutika. Okay, done. Okay, I hope this point is done. Moving on. Okay, expanded form of decimal. Okay, fine. So this is the expanded form of decimal. This we have looked into it already. Okay, so that place value, that is 2 is in ones place, 8 is in 10th place, 1 is in 100th place, and 6 is in 1000th place. Okay, 6 in the 1000th place. This is the expanded place value form. Decimal form, we can write it as 2 plus 0.8 plus 0.01 plus 0.006. Okay. Fraction form, how can I write? 2 plus 8 by 100, 1 by 100, 0.006 as 6 by 1000. 6 by 1000. I hope it is clear. I hope it is clear, guys. Okay. Let me tell you again. So the first one we have already done. We have done in the example part. Okay. Second one, 2 plus 0.8. Okay, because it is just after it. Then 1 is at 100. So 0.001. Sorry, 0.01. And 6 is in 1000. So 0.006. Okay. Now convert this into fraction. It will be 8 by 100. Convert this into fraction. 1 by 100. This into fraction. 6 by 1000. 6 by 1000. Okay. And I can see a message. Okay. Done, guys. Okay. Understood. Understood. Okay. Very simple. Okay. Very simple. Note it down. Okay. Note this down. That's it. That's it for this particular session. Okay. Same energy needed for coming up session. Okay. Note this down. That's it. Okay. Note this down without fail. Then we will start with this only from our next class. Okay. This part itself. Okay. Done, guys. Take the break. Okay. Welcome back, guys. Okay. Ready. Everyone. Okay. We had a good break. Everyone is ready? Yes. Come on. Done. Come on, guys. Ready? Yes, no, come on, come on. Ready? Yes. Okay, done. Welcome back, welcome back. Ready, 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 ready. Okay, everyone is ready. Okay, chalo. Let us start. Okay, so let us revise this part again. That is the expanded form. Okay, so that is 2.816. Okay, 2.816. So 8 is in ones place. Sorry, 2 is in ones place. 8 is in tens place. Ones is in hundreds place, and 4 is in, sorry, 6 is in thousands place. Okay, fine. So that is 2.816. That is 2.816. Okay, so same in the decimal form. How can we write? 2 plus 0.8 plus 0.01 plus 0.006. The same we can convert into fraction. 2 as it is. 8 we write it as 8 by 10. 0.01 we write it as 1 by 100, and finally 0.006 as 6 by 1000, Okay, fine, clear. Chalo. Okay, sir, we can find the factors in other way. Okay, 1 into 8, 2 into 8, 3 into 8. So yes, that is your pairing, correct? You are pairing the factors, correct? Absolutely correct. No issues with that. Okay. Like and unlike. Okay. Fine. Like and unlike decimals. Okay. First, let us look into it. Decimal having same number of decimal places are called like decimals. For example, 5.45, there are 2 digits. 17.04, there are 2 digits after the decimal point. 272.89, again there are 2 digits, 8 and 9 after the decimal point. Now decimal having different decimal places after the decimal point are nothing but called unlike decimals. So that is 7.5, 23.1. Once you can see 1 digit here, you can see 2 digits here, 1 and 6, and here 0.054. There are 3 digits over here. Clear to everyone? Yes. Okay, fine. So unlike decimals can be converted into decimal by adding the zeros after the last digit. Okay, for example, you can see 7.5, 23.16 and 31.054. These were all unlike decimals, correct? Unlike decimals. So how can I convert into like decimals? Okay, how can I convert into like decimals? Okay, all these clear? How can I convert into like decimals? So all I will convert into 3 digits. Okay, 500, 16, add a 0, and this is already a 3 digit, so a 3 digits itself. Okay, fine. All the 3 points are very important, including the example point of view. Okay, please note it down. Okay, please note it down point by point. Any doubt? Chat box is open. Please ask me. You can give a direct message. My name might be displaying. That is Vivek Roy Chaudhary. My name might be displaying. You can give a direct message to that. Okay. Yes. Yes, Yadav. Can we use the restroom? Please make it quick. Come quick. Can you explain like term? See, there is 1 decimal point. There is 1 decimal digit after the point. There are 2 here. This is 516054. See here 1 digit, 2 digit, 3 digit. I want to convert all into single. So all of them I have converted into 3 digits. 7.500. 23.160 and 31.054. Okay. Very good. The table just shows the converting unlike term to like terms. Video is blurry. Now many of you are saying the same thing. Just a second, let me look into it. Screen is blurry. स्क्रीन ब्लरी हो चुकी है नहीं मैं हमारे यहाँ पे भी आ रहा है सेम ब्लरी स्क्रीन ब्लरी आ रहा है एक बार चेक कीजिए On it guys, on it. I can see many of you have said the video is blurry. Okay. Okay. Now it's okay, sir. Okay. Fine. Okay. Yes. Okay. We have just a bit of network issues. No issues with that. Okay. Meanwhile, you can prefer your okay, you can just look into the PDF which were given in case needed. Okay, I hope now the screen is pretty clear. Yes, you have to write down the table. You have to write down the table. Table part is very important, that is converting into like to unlike. Everyone? Written? Written, make it quick. Okay. Waiting for last one more minute, make it quick guys. This is the last class, yes. Till 11:20. 40 minutes more. It was blurry, now it is pretty clear. Please check your or reconnect. I would suggest reconnect once. Done? I understood, sir. I have already learned. Okay. For already learned people, please look into it as a revision part then. Okay, it will help you. 31.054 is like or unlike decimal, sir. 31.054 unlike to what? See, when are you saying like and unlike decimal, you have to compare. You have to you are comparing with what? Let me know. Unlike decimal, after the point there are unlike digits. That is, let us suppose 7.5 is there and 23.16 is there. So in 7.5, how many digits are there after the point? After the point 1. And in 23, how many digits are there after the point 2? So that's different. So those are called unlike decimal. Okay, clear? Done everyone? Okay, let's move to the next. Okay, now comparison. Okay, comparison of decimal points. Okay, very important topic. Okay, very important topic. Everyone, please look into it with at most concentration. Okay, please, at most concentration is needed. Okay, clear to everyone? Yes, let us start. Comparison of decimal is same as comparison of numbers. The following steps need to be followed. That is, compare the whole number part first. Okay, whole number part you know how to compare. Okay, that is 2 is greater than 1. Okay, you know those type of comparisons. Okay, now if the decimal part is same, then the decimal number with greater whole number part will be greater. Okay, for example, now look into it. Okay, first 52.432 and 45.989. Okay, which is greater? Everyone in the chat box, come on. Now time has come. Come on, which one is greater? Come on, make it quick. Very nice. First one. Everyone, very good, very nice. Okay, first one, that is 52.4432. You should not get confused with the decimal point here. Sir, decimal is big. No. First comparison is whole number, that is left hand side of the decimal point, that is 52 and 45. 52 and 45. So here it is pretty clear that it is 52.45432. Perfect. If now the second case, if whole number part is same, then observe the decimal part. Okay. If they are like decimal, then compare the like decimal part of the 10th followed by 100 followed by 1000 and so on. If they are unlike, then convert into like decimal and then compare. Okay, let's see example. Okay, first of all, before answering, are they like or unlike? First, are they like or unlike? Like, sir. Perfect. They are like. Okay. Why like? Because there are 3 digits here, 3 digits here. Okay. Now, are their whole numbers same? Yes or no? Are their whole numbers same? Yes or no? Yes. Perfect. Whole number means left hand side of the decimal, 60, 60. Now compare tens. If 10th is also same, then 100. If 100 is also same, then 1000 and so on. Now check here. This is 8. This is 5. Okay, 8 and 5. Obviously, 8 is greater. So what's the answer? 60.802. Okay, 802. First one is the answer. Perfect, guys. Everyone, beautiful. Lot of energy, beautiful answers, everyone. Very good, very nice. Okay, next one. Okay, now, first my question, like or unlike? Like or unlike? Like or unlike? Unlike. Very good, everyone. Very good. Okay, this is unlike. Why? Because there are 3 digits. Okay, because there are there are 3 digits, 2 digits here. Okay, so first I have to make 5.248 and 5.240. Now did I make into like or unlike terms? Now are they like? Yes or no? Okay, yes or no? Now they are like or not? Yes, they are like. Now compare. 5 is same. Yes, 5 is same. 2 is same. 2 is same. 4 is same. 4 is same. Now 8. Okay, now 8. 8 and 0. Obviously, 8 is greater. So what's my final answer? 5.248. 5.248. Clear? Understood the step, guys? Yes or no? Any doubts? Please let me know. Clear? Yes? Clear? Very good. Very good. Good energy. Okay. Good energy, guys. Loved it. Okay. Very good. Very good. 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 Okay. Can we move to the next? Can we move to the next? Yes. Yes, 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 yes. Okay. Chalo. Let's move to the next one. Okay. Now, next important topic. Any doubts in comparison? Okay. In comparison. Any doubts in comparison? What happened, Sohil? Okay. You're not seeing my chat. Ardhya, I am seeing your chat. Don't worry. We didn't write. Okay. 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 See, I'm showing all the slides. You can write it up. Okay. This was the previous one. Written. Written. This one. Like or equivalent fractions are same? No. No, Pragna. Like and equivalent fractions are not same. Okay. Like fractions only there are decimal. Whereas equivalent fraction, they exactly have to be same. The answer have to be same. Okay. Next one. Okay. You can write this up. Giving you 1 minute of time, make it quick. Then we will move to addition and subtraction of decimals. Surely you can start the worksheet, guys. No issues at all. Should we compulsory do the process? Process is compulsory now, okay? Because currently you are not writing any objective paper, right? So currently you are understanding. So process is important. Yes, class is still 11:20. Yes, you can please check addition and subtraction in the PDF. No issues. Done, done, done. I hope it is done by everyone. Anyone still writing? Please let me know. Anyone still writing? Please let me know. Done. Okay. Next. We can move to addition and subtraction. Yes. Okay. Chalo. Let's continue. So for addition and subtraction, addition or subtracting decimal, the following steps, okay, the following steps are needed to be followed. Okay, what are the steps? Converting the decimal, okay, this converting the decimal, okay, converting the decimal part, okay, to be added or subtracted like a decimal, okay, like a decimal to first. So what is the first step? Then arranging, okay, first step is simply writing down the decimal point, then arranging in a such a way that all of them are in the correct place value of it. In short, the decimal point should be aligned all in the same order. All should be added in the same order. Okay, fine. Addition or subtraction using the column subtraction can be kept very easily. Is it clear to everyone? Yes, okay. So the main important point here is all of them must be on a single row or the single column. That is, the decimal point should be aligned in the same order, that is same line. Okay, fine. Let us see an example with the help of this. With this, we will get a better idea. Okay, we will see the example. Everyone, please look at the example. Okay, so that is 13.25. 13.25 and 0.075. Okay, 0.075. Now, if you can see, I wantedly added a 0 here. Okay, please see. First, are they like fraction or unlike fractions? Like fractions or unlike fractions? Yes. From 6th to 10th, I teach everyone. Correct? Unlike. So I am making into a like fraction first. I am making into a like fraction first by adding. If you look into the point, my all decimal points means there are two decimal points only here, is lying on a same line. Okay, same line. See, under the tens, under the hundred, under the thousand, and these two are the digits. Okay, now see, I am adding them up. How I am adding? 5 plus 0 plus 5, 5. 7 plus 5, 12. Carry over 1. Okay, that will give me 3.31. Okay, I hope this is clear. Any doubt, please let me know. Okay. Any doubt, please let me know. Make it quick, write it down. Okay, write it down, no issues. I can see everyone's chat, guys. In tens place, yes, you can add the 0 in the tens place. That's not an issue. You're talking about this, right? To add 0, you can add or you can leave it. No issues. That's your choice. First, you should make it into like fraction. That is better. Yes, Priyansh, I can see your chat. Junaid, done. Okay. It is fine. If there is nothing, it's defaultly 0. You can add it or not. Okay. Yes, subtraction we are going to do next. Don't worry. Okay, before slide. Okay, first note this down. Then we can look into the before slide. That would be the revision part I will be doing. Every slide I will be showing you once. Don't worry. The last 5 to 10 minutes we will be looking through that only. Okay. Done. Done, everyone? Okay. Yes. Okay. Let's move to the next one. Okay. Now a real life application question. Okay. What's the question? In an application carnival, class 6 collected this much amount. 5A collected this much amount, 5B collected this much amount, 5C collected this much amount. What is the total collected? Classic example of adding all of them. Okay. 5A. Okay. How much is that? 1, 1, 9, 2.75. Okay. Next. 5B. Okay. 1, 2, 4, 7.5. Okay. Please note the point, I am not moving my decimal point, all are here. So as there is an empty space, to convert into like decimal, I have added a 0. Next, plus 5c, that is 1, 2, 9, 8.05. Clear? Yes. Clear to everyone? Clear to everyone? Yes. Okay. Fine. Now please add them up. Please add them up. Very simple. Now simple addition. No need to worry at all. 5 plus 5, 0. Carry over 1. Okay. 7 plus 5. Quick. Good. 12. Carry over 1. 13. 7 plus 2, 9. 9 plus 1, 10. 10 plus 8, 18. Put the decimal point as it is, carry over 1. Simple addition now. No need to worry. Okay. 9 plus 4, 13. 13 plus 10, 23. Carry over 2. Okay. 2 plus 2, 4. 4, 5, 5, 7. Okay. Here, 3. Okay. Clear to everyone? Yes. This is the final answer. Okay. This is the final answer. I hope it is clear. Any doubt, please let me know. This is for 5th C. Okay. Thank you, Richard. Thank you. Done? Is the video blurry? I don't think so. The video is blurry now. It is pretty clear, even in my device. It is pretty clear. Please check your connectivity. I think so. It is pretty clear. Okay. Yes. Can you explain addition and yes, we are currently doing the addition part itself. Okay. Very good. Very nice. Clear to everyone? Yes. Okay. Good. Fine. Let's move to the next one. Is it done? Can you have some water? Yes, please have it. Done, everyone. The screen is not blurry, Baba. I can see it very clearly in my screen. Please check your connectivity once. Anyone still writing? Please let me know in the chat box. Make it quick. Anyone still writing? See, Hardik, please look into it. First, I wrote all the decimal point. The only unlike decimal was 1247.5. Okay, so I added a 0. Then simple addition, 5 plus 5, 0, means 5 plus 5, 10, 0, carry over 1. 7 plus 5, 12, 12 plus 1, 13, carry over 1 again. All these circles are carried. Okay, 7 plus 2 is 9, 9 plus 8 is 17, 17 plus 1, 18. Again carry over 1, 9 plus 1 is 10, 9 plus 4 is 13. 13 plus 10, 23, carry over 2. 2 plus 2 plus 2 is 6, plus 1, 7, 1 plus 1 plus 1 is 3. Okay, please use the restroom, Baba. Okay, I hope this is clear. Moving to the next one. Okay, next one. Okay, so Kamal and Akhil were both sick. The doctor measures their body temperature. with a thermometer. The doctor said Kamal holds a temperature of 102.12 Fahrenheit and Akshay is 1.38 Fahrenheit. Okay, that is less than, okay, 1.38 less temperature than Kamal's body temperature. Okay, don't think that that is 1.38. Okay, no one's body temperature would be 1.38. 1.38 means he is dead. Okay, fine. Fine. So please read the question that Akshay was 1.38 less temperature than Kamal's body. So what was Akshay temperature? Yes. Should we do addition here or subtraction? First tell me that, guys. First addition or subtraction? Make it quick. Addition or subtraction? Subtraction, subtraction, subtraction. Very good. Good, guys. Good, 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 good. Okay. Now let's write them up properly. Okay. Okay. So that is 102.12. Okay. 12. This is the temperature. Less means subtraction. Subtraction. Again, the same rule will apply. That is the decimal point. The decimal point should be in the same line. Okay. That is 138. Okay, 138. If you want, you can fill up the zeros here. Okay, if you want. Not needed. Okay, absolutely not needed. Just the digit will come down. Okay, so if you want, you can fill up the zeros or not needed. But here, this side it is needed to convert into like fractions. But they are already in the form of like because both the sides there are like fractions. Correct? Now answers. Answers. 101.12, okay, 100.74, okay, 100.74, okay, come on, I'm waiting, okay, so first I have to take carry, I have to make this as 0, taken carry, I have to make this as 12, so this will become 4, okay, again 0 is less than 3, so taking a carry, 1, and this will make it 10, correct? So which will make this as 7. Point as it is, 1, 1 is same, so 0, so 0, 1. Okay, so this is my final result. Okay, 100.64, please do the subtraction carefully, everyone. Yes. Done. Easy subtraction question. Okay, writing up it properly. Let me rewrite it properly. Okay. I hope it is clear now. Done. The main important step we should not forget is decimals. Both in addition and subtraction, all the decimals should be in a one single line. Okay? Yes. That is a word problem, sir. Yes, correct. Absolutely right. Sir, 1 should be 9 since it is borrowed. No, 1 will become 0, na? Then it becomes 10. You can cross verify, no? 8 plus 4, 12. 12 carry over 1. You can just cross verify. You can cross verify how? Whether your answer is correct or not. 100.74, 1.38. Okay. Cross verify, you should get 102.12. You can cross verify. 12 carry over 1. 7 plus 3, 10. 10 plus 1, 11. Carry over 1, 2, 1, 0. This is a cross verification check. Okay. You should use words, right, sir? Use words. Words I didn't get you. Thank you, Richard. Sir, red color. Okay. We'll look into that. Done, done, done. This is just a cross checking. This is not a procedure. Someone asked me that the borrow should. This is just a cross check. Okay. This is just a cross check. Done, everyone? One should be 11. No, one should not be 11. No? Why it will be 11? It is already 1 and 1 is same. We should take only borrow if it is less. Purple and red is not matching with the screen. Okay. So I am using only yellow and white. So light blue, it won't be looking good because of the blue background. Green, yes, we can try it up, no issues. Okay, yes. Fine, I hope this is clear. Yes. Okay, multiplication of decimal, that we will look into in our next upcoming sessions. Okay, fine. First, this is will be our next topic. Let's quickly revise. Okay, quickly revise each and every point that we have discussed, because we have discussed a lot of topics today. Okay, lot of topics today. Let us quickly revise. And the people who have missed the slides, please be attentive now. Please look at the slides. Okay, fine. Okay, so from here we started. So we will look each and every slide again. Okay, that's it. Okay, first we look at the place values. So started with hundreds, tens, ones, then hundredth, that is tenth, hundred, and thousand. Okay, hope this part is clear. Next, we converted decimal into, that is the decimal fraction into decimals. Okay, that is 6 by 10. So what is decimal fraction? First of all, the denominators with 10, hundreds, thousand, these are called decimal fractions. Okay, so as there is a 1 0 and 1 digit, so 0.6, no issues. Now there are 2 zeros but 1 single digit, so 8. So I made it into 2 digits. How? 0.8. So it became 0.08, as simple as that. Then 15 I made it. 15 I made it into a 3 digit. Why 3 digit? Because the denominator has 3 zeros. I have to make it into a 3 digit number. So that is 0.015. Okay, so that is converting into a normal fraction into decimal. Okay, so first 5 can I convert into 10? Yes, I can convert into 10. How? By multiplying with 2. So I have to multiply 2 with both numerator and denominator. 4, can I convert into 100? Yes, I can convert into. Can I convert into 10? No, I cannot. Okay, it's not a factor of 10, but it is a factor of 100. Yes, it is. So 4 into 25. So both 25 numerator and denominator. Okay, so we get 75 by 100. Okay, 75 by 100, we get 0.75. Then 8, I am multiplying with 125. 8, I am multiplying with 125 to get 1000. Again, which will convert into 0.625. Now, converting, this part is very simple. That is converting a decimal into a decimal fraction. That is count the number of digits which are there after the decimal point. 1, 2, there are 2 digits. So, divide by 100. If there are 3 digits, divide by 1000. If there are 4 digits after the decimal point, okay, that is divide by 10,000. Very simple. Okay, fine. We can also simplify them by their common factor. You can divide 122 by their common factor. Okay, I divided with 4. So 112 divided by 4, you will get 28, and 100 divided by 4 also you will get 25. Okay, fine. So you can make it. Clear to everyone? Yes. Done. Next, 112 by 100. Okay, 112 by 100. So 1 plus 0.12, 1 plus 0.12, and 15.4 as 15 plus 0.4. And 0.4 you can write it as 4 by 100, the another way. Okay, clear? Next, the expanded form. There are three ways of expanded form. One is the place value form, one is one is decimal form, and one is fractional form. Okay, I hope this point is clear. Next, like and unlike. So after the decimal points there should be same number of digits. Okay, if they are unlike digits, we can convert into like decimals. How? There are 3 digits here, just adding the zeros towards the right hand side, adding the zeros towards the right hand side. Then we did comparison of fractions. First, if the whole number itself is greater, no need to compare itself. The whole number which has a greater value, that itself is the greater value. If the whole number is same, then we move to the decimal part. Okay, here you can see 8 and 5, 1 digit. First we go to tens, then hundreds, then thousand, and so on. Okay, fine. Next, 1C, you can clearly see here, tens was same, hundreds was same, so we finally compared with thousand. Okay, thousand, if thousand also becomes same, then we will move to 10,000. And if that's also same and it is ending there, then we see both the decimals are equal. Okay, next, addition and subtraction. We lose the major point, the last topic. Okay, what is it? Addition and subtraction. The major last topic is aligning all the decimal to a single line. Okay, single column. Okay, fine. So that is, you can see here clearly, I aligned the decimal in the single column. That is the addition part. This is a word problem which we did. Okay, you can see I have aligned all the decimal on a single part. After aligning, simple addition and subtraction. No need to worry at all. Okay, next, subtraction over here. How to do? Okay, reason being it is less. Okay, it is less temperature. Less temperature itself indicates that I have to subtract. Okay, clear to everyone? Yes, that's it. Okay, next class we are going to discuss about multiplication of decimals. Okay, don't miss any of the classes. Practice well. Any doubts which I have missed, we will be taking up in the Saturday session. You don't have to worry at all. Revision and practice is must. Don't look maths, write maths. Practice it. Okay, fine. All the best. Do well, guys.